Welcome to the lesson 1.1 geometry notes. Identify points, lines, and planes. We'll be walking through the lesson. It's a very vocab heavy lesson, so there's not a whole lot of, uh, initially at least, examples. So we make sure we get our notes as far as adding these definitions, abbreviations, symbols. I'm going to kind of talk through some of the highlights as we go through. So let's do it. Our main objective is to identify, describe, and abbreviate geometric figures. Mainly these three, but there will be others as well. So we end up with three. Let's kind of look at one at a time here. We end up with three what we call undefined terms because really it's hard. They're hard to define without or other than using that term in the definition. So we're going to work with an understanding of what they all mean. These will be our three undefined terms: point, line, and plane, that we'll use to define other words from here on out. Okay, so we'll look at them individually. Our first one is just what we call a point. It has 0 dimensions, so no length, width, or height. It's infinitely small. It's basically a dot. We use a dot to represent a point. And we say point. Make sure you say point A. So here's a good example. There's our dot. There's our name for that point. It doesn't have to be A, but we use capital letters. Point A. All right. Our next one, our line. These you should be adding these to your notebook. This is how we did it in class. A line has a single dimension, length. It's represented by a line with 2 arrowheads, so arrows on both ends. And that's to represent that this extends, even though our drawing stops here and here. These arrows are implying that this continues far off the screen this way, and as far as we can go infinitely this way. It extends without end. Okay. The big takeaway is how to name and describe and talk about lines. So there's a couple different options we have for naming a line. When given the option, we could name this line using, there would be a little cursive letter. In this case, it's an L. So we would say line L would be one option for naming this particular line. Okay, there's no abbreviation for that. You have to write out and say the word line L. The other option would be to use any 2 points on that line to name it. So again, we kind of have if we're going to use that method of naming of this line, there's only one option to do it. Well, 2, I guess. You could name this line AB, because these are, I can see from above, these are 2 points that are on this line. I could also call it line BA. It doesn't really matter the order, left to right, right to left. Here, the big abbreviation, because we don't always want to write out the word line. I can take that off there. I can just use the points A and B, and it's kind of hard to tell, but there's a double arrowed line right above the A and the B, or in this case, line BA. I would still say line BA if this is all that I saw. I said, hey, what's the name of this line? I would say line BA if this was all I was looking at. You say line BA. Okay, so there's lines, 1 dimension, arrowheads on both ends, extending forever, and that's the ways that you would name it. Our third undefined term is a plane. Okay, has 2 dimensions, like a length and a width dimension. Great representations for a plane would be a floor, a wall, your desk, a table, your whiteboard. Any flat surface is a good representation. It still works like a line in that, although our drawing stops because we just out of space purposes we can only draw so big, it's implied that this extends, it keeps going. This flat surface keeps going forever that way, down, left, right as we look at it. Okay, so it's a big, just kind of single plane flat surface. Just like above, there's very specific ways to name a plane, to talk about, to describe a plane. First off, let's say there's no abbreviations. There's never a case where you'll be abbreviating a plane. You're always going to write or say plane, but there's, just like above as well, there's 2 different ways to do it. You either use 3 non-consecutive or 3 points that are not in the same line, so I can see that A, B, and C are not on the same line. I can use any combination of those points and say plane ABC or plane CBA. M is not an option. Why? Because it's not a point. Going back to the first thing we said, there needs to be a point by this M to make it a point, and it's not a point. This M right here is acting kind of like this cursive L was for our line. It's a separate just name for this plane. Okay, so I could say plane M and just use that single name. It would be a capital letter in the corner of your plane, and there would not be a point by it. Sometimes you have this option, sometimes you don't. If there was no M here, it would kind of force us to say plane ABC. Okay, so there's our three undefined terms: point, line, and plane. There's some specifics on how we name them, how we abbreviate them. Make sure to add that to your notes. All right, right along with that, kind of building on that, still really just kind of extensions of some of those definitions. When we say collinear or coplanar, it means we're talking about multiple points. It's either collinear is referring to points that lie on the same line. Okay, so kind of using some of the information that we just covered, this line L would be one way to talk about this particular line right here. I could say line L contains points C, E, G, H, and J. I could also say points, or say or write points C, E, G, H, and J are collinear on line L. Would be another just way to converse or talk about or describe this figure. Coplanar works exactly the same way. It's points that lie in the same plane. Add both of these definitions to your notes. We could say points P, Q, R, and S are coplanar on plane T. Or points P, Q, R, and S are coplanar on plane PQS, if I wanted to name it a different way. So that's collinear points and coplanar points. We need to understand what that means. That could be a direction. So let's take a look. Let's take a look at types of questions that go along. Our first example for the lesson. We've got a figure, a lot going on in the figure. As far as it looks like I can see a plane here with several points on the plane. I see the dots representing points. There's also some letters here. I see a Z, I see an A, I see a lowercase a and B, I guess, that they don't have points with them. So that means something else to me. So I'm just kind of breaking the picture down a little bit. But I've got 1, 2, 3, 4, 5 different questions, kind of all just going through what we just talked over. So let's take a look. The first question, or just first direction, give 2 other names for line LN. So I see this just like we said. And when I see that, it's not just some random symbol. This is it's an abbreviation for line LN. So line LN is referring to this line right here. So I want different names than LN. The first one that I see, if I wanted to kind of just use a single name for it without a point, I could say this is line B and actually write out the word line B. Perfectly acceptable. That's a different name for that line. I could flip the letters and say, okay, I want a different name than LN, but still talk about this, what I've kind of highlighted in red. I could call this line NL. Totally acceptable. If I wanted to abbreviate that exact same name, I could shorten it up and just go line NL with the double arrows above it. These are the same. Okay, however I write it, line NL or line NL, I'm saying the same thing. Okay, so that's another option. I'm not going to list them all. These are just examples. Let's do one more though. Anything involving M and N or M and L, as long as you're only using 2 letters, the order wouldn't matter. So as a third option here, again, this is not all of them. I could also go with maybe just an abbreviation if I wanted to say something like line M N. As long as I put the arrows with the line above it, I would be correctly using that abbreviation, line MN. Okay. Second one, give another name for the plane. So now we're going to switch it up and say, let's talk about this plane, the entire plane. Maybe I'll take the red one unhighlighted here. talking about plane Z. Okay, so we talked about different ways to name a plane. I need to use 3 points. This one's kind of out the window for us. The directions took away the easy one. So I need to name this plane a different way. I need to use 3 points that are in that plane, but it's restricted in that I can't pick any 3 that are on the same line, or to use a vocab word, that are collinear. So in this case, the one that's kind of off limits for us would be to say plane LMN. Those are collinear points. I can't use those. I need to get P involved. Q is also off the table because that's not in the plane. It's kind of hovering above it. You got to think a little bit three-dimensionally here. It's kind of floating above the plane. So any combination that involves P, it has to include P, and then pick 2 of the 3, L, M, or N. Okay, so I'm going to say, and again, if I'm going to say it, I need to write that word. There is no abbreviation for plane, so I need to write out the word plane, and then you've got your choice. P, I'll go LM. No commas. Plane PLM would be a perfectly acceptable way to rename this plane. Let's do one more. Plane, take your pick. Let's do a different one. N, M, P. NMP would be an NMP. Totally acceptable way to name that plane. All right. 3 collinear points. Pay attention to kind of some of the specifics here. Notice I didn't use commas here. I'm not separating. I'm not listing at points, which I'm actually going to do here in part C, which is what kind of triggered my memory there. Here we can make a list. Name 3 points that are collinear or on the same line. So I think we're talking, we kind of only have one option here as far as this group. I have a point L, point M, and point N, which all fall on the same line. The order doesn't necessarily matter. I'm going to work just left to right. So I'm going to say points, and then now I can make my list. Points L, point M, and point N. So that's kind of a shorthand way. You could obviously write out point L, point M, point N, but if I wanted to save a little bit of writing there, I can just make a list of points. Similarly, for part D, I can go with just listing points. It's asking us to name 4 points that are coplanar, that lie in the same plane. Be careful. There's some extra stuff here that we want to avoid. Z, remember, is not a point. It's the name of the plane. And B is also not a point. They are, that's the name of this line that we named originally, line LN. So I definitely do not want to involve Z or B in naming and listing points here. I think kind of similarly, I don't have, I don't really have a ton of options. There's points L, M, N, and P, and those are really the only points that are in that plane. So if we list them out, similar to above, points, let's see, we said L, M, N, and P. Those are our 4 points that are coplanar. For part E, the last one here, we've covered kind of, I think, every point on there. If L, M, N, and P are coplanar, the one point that is not coplanar with them is points L. That is not coplanar with points L, N, and P. M is on that same plane. We just said it in part D. Q, that was the one that I mentioned before as far as like hovering above kind of. It's on a line that's shooting through line QM, is meant to be kind of like poking through the plane, through plane Z. So that puts point Q, and again, I'm saying the word point, and I'm also writing the word point. Do not just say Q, as far as like an alternative answer. Q by itself with no other point in front of it wouldn't mean anything to us. We want to say point Q. Okay, so there's an example of how I would assess, do you understand really the language of geometry, our initial vocabulary. All right, let's keep moving. Still some vocab to get through here to cover in this section. Okay, now that we have we're working with an understanding of what a point, what a line, what a plane is, we can use those now to help us define actually some other words. Okay, so we're going to start with, and that's kind of what this is saying, we're going to use those definitions, points, line, and plane, to help us define these segment and array. So let's take a look at segment. A line segment, we'll usually just call it a segment. We can assume that we're talking about a line segment. It says it right here, segment AB or segment BA. It's basically, and I'm summarizing, it's a part of a line, right? If line AB is everything that's starting right here, that goes forever this way and forever this way, we're talking about an infinite piece that we can't really measure. It goes on forever, whereas a segment is a piece of that line, all right, consisting of endpoints A and B, kind of a beginning and an end, or beginning and an end. It doesn't really matter left to right, but we have the ability to measure, whether it's a ruler or whatever. I can measure this segment. It has length. Okay, abbreviation, writing wise, just like before, I'm actually going to write this one out here. It's highlighted right here. We could call this segment AB or BA, but the abbreviation changes when I start talking about line AB versus segment AB. The difference in abbreviation is literally some arrowheads, but we're talking about two different things. We're talking about an infinitely long line forever in both directions versus a very discrete, measurable piece of that line, segment AB. Okay, so you got to be really careful with what you're referring to when you're talking about those symbols. Okay. Our next one, array. And again, I'm going to summarize here just to kind of clarify this definition. It's not truly half of a line because, again, we can't have half of something that's infinite, but it's really starting at one endpoint, putting an endpoint on a line, and going in a single direction from that endpoint. Okay, so in this example here, I've started at point A, and I want to talk about all the points that fall on this side of point A. Differently, this is a different ray down here. Line BA starts at point B and goes forever in this direction. Okay, so we've seen some that are interchangeable. Segment AB, segment BA, yep, we're talking about the same piece right there. Line AB, line BA, we're talking about the same thing, forever in both directions. When I start talking about rays, I got to be very specific. If I'm talking about ray AB, I'm talking about starting at A and going forever that way. There's some overlap for sure. Segment AB is contained in both rays, but all this stuff that we're including, all these points out here on ray BA, that is not included on this ray. Okay, so these would be actually two different figures, even though they look the same or they look similar. We're talking about two separate things. So you can see it. I'm going to kind of highlight it again. We've got really our third similar looking symbol with the single arrow above it. Okay, and they always face to the right. It really doesn't matter. You can kind of see here that ray BA, even though it looks like it's going to the left, we still write the arrow as far as pointing to the right. Okay, that's just kind of that's just the way that we do it. But they are different rays, and that's highlighted here. Okay. The last piece that we'll look at, there's a definition here, the opposite rays. This definition I think is a little bit confusing. If point C lies on line AB between A and B, then rays CA and rays CB are opposite rays. I think if we highlight them in maybe different colors, it illustrates it. So if I looked at line CA starting at C and going forever that way, and looked at ray CB and everything that way, we're basically, other than the endpoint, that's the only overlapping point, we're covering every single point on this line as far as including them. So we would say, right as it's said here, ray CA, so the pink one, and ray CB are opposite rays. One way to kind of think about it, maybe just differently here, would be it's got to meet these criteria that one, they've got to be on the same line, and this is no particular order, but they need to be on the same line. They need to share a common endpoint, and they need to go in opposite directions. And that's a little less formal, but I can give you some illustrations here as far as maybe some examples that look like that could potentially be opposite arrays, but actually aren't. So if I looked at maybe a array B, BA, there's array BA starting here, and array CD. Okay, do they fall on the same line? No. Do they have a common endpoint? No. Okay. What about something like this? So this would be an example of not an opposite array. What if I had something like this, that I had array X, Y, there's array, definitely array, and I also had array X, Z, two separate arrays, maybe highlight it here in a different color. Array X, Z, definitely different, two separate arrays. They do have a common endpoint. They kind of, you could argue they go in opposite directions, maybe not though, but I would definitely say they are not part of the same line. They're not contained on one single line. So that's another example of nope, that's not good enough. The other one you might see would be similar to this, that I could have array BC, and I could also have maybe array X, Y. Okay, they're actually going the same direction, right? They are on the same line, because we could extend this and that would be the same line. They also miss the criteria of a common endpoint. Okay, so I just wanted you to see a couple examples of maybe some not. Sometimes it's helpful to see the not opposite arrays to kind of illustrate what an opposite array actually is. One last thing, just to kind of summarize just what we've talked about there. If I were to take this figure, got some arrows here, throw a few points, A, B, C, and D, maybe even name our line M. I've just drawn, I believe, other than our plane, we're not talking plane here, any line feature we've talked about. I've got line AD, which we could also name line M, line DC, line BC. I've got some collinear points on that line, on line M. I have segments AB, segment AC, segment BD. There's a bunch of segments up here that we could all name, and we're just talking about those individual pieces. And we've got a bunch of arrays. We've got array B, array BA, for example. If I wanted to describe everything starting at B going in that direction. I have array CD. Okay, I've got array CB, and those would all be different. So on any given figure, we have quite a few different features here. We even have some opposite arrays, right? Array CB would be an opposite array of array CD. Okay, they share an endpoint, they're on the same line, they're going opposite directions. So everything we've covered line-wise, segment-wise, can be contained in any single figure. Let's look at an example again, kind of applying some of those concepts. It still really comes down to naming some of these different figures. So again, we've got our figure. I've just got a couple lines. Looks like they're crossing here at this point W. First direction is asking us to give another name for, here I'm paying attention to my symbols, segment VX. So let's highlight it here. I kind of like to know what I'm talking about. Where is segment VX? It's only from right here to right there. So I'm not talking about anything beyond out here or out here. It's just from this section to from V to X. Okay, so I need another name for it. I think the only option I'm going to end up with is flipping my letters, my endpoints around. I can't involve W because anything with W is going to cut off part of that section. So I don't want to do that. So I think our only option here would be to flip our letters and say segment X V and still be talking about the same segment, same line segment. Okay. If I were to look at part B here, it says name all rays with endpoints W. We're kind of starting in the middle. Endpoints W. It looks like I've got a ray kind of going this way. I've got a ray starting at W going this direction. I've got a ray starting at W going this direction, and a ray starting at W going this direction. So if it wants me to list all rays with endpoints W, it looks like I've got 4 as I've kind of colored them here, 4 different rays. So if I want to use my symbols correctly, I'm going to use ray WY. I'll just go in the order that I wrote them down. Ray WY, comma, ray WV, comma, ray WX, and ray WZ. Okay, so there ends up being 4 of these. Which ones ends up being opposite rays? There's really 2 pairs of them, right? So WY, let's just list them out here. Hopefully our definition of opposite rays is kind of stuck here a little bit. They need to share a common endpoint, which they all are, but basically the ones kind of on the same line are going to end up. So I've got a pair. Pair 1 would be WY, ray WY, and ray, kind of erase here a little bit, ray WZ would be opposite, a pair of opposite rays. And I do have a second pair starting with WV, so WV, ray WV, and ray WX would be my opposite pairs of rays, or opposite pairs of opposite rays. Sticking with the ray theme here, I'm going to kind of clear our markings just so we have kind of a clean slate to work with here. Give another name for, here we go. What is this line? Is this a segment? Oh, I can see it's tiny. It's kind of small, but I can definitely see that there's an arrowhead, just a single arrowhead. So we're talking about ray YW. So I know it has to start at Y, pass through W forever. So this direction. This is a good look at one we didn't talk about actually earlier. I can name that exact same ray in a different way. I just need to name any other point that falls on this side of Y. Okay, yes, of Y. So I've already used W, ray YW, got us going in this direction. I could also call this ray YZ and be talking about, starting at Y, passing through Z. I'm still covering the exact same ground. So we could call ray YZ an alternate name for ray YW. Lastly here, let's take a look. Clearing the board. Are ray VX and ray XV the same? This goes right to what we had talked about really with the definition. Let's highlight them. I like that. I like to be able to see kind of what we're talking about. So where's ray VX? It starts here and goes forever this direction. Okay, we're cutting off basically everything over here. From V from V in this direction is good. Whoops, in this direction. Everything over here is not part of that ray. And the flip would be, all right, where's XV? It starts here. I'm going to kind of just drop it down a little bit. Whoops, different color. Ray XV starts at X and passes through V and goes that direction. So is there some overlap? Absolutely, 100%. Every point in this region on this segment is contained on both rays. But we can see, I think, through the colors that the blue is going to extend well beyond where the red one goes, and vice versa. Same thing here, that the red extends beyond where the blue kind of starts or stops. So to answer the question, are they the same ray? No, they're not even opposite rays because they don't have the same endpoint. Okay. As far as an explanation, are they the same ray? No. They don't share an endpoint. Would really be enough to kind of take that off the table. No, they do not share an endpoint. Just like above, we said YZ and YX were the same. YZ and YW were the same because they both started at Y and went this direction. These have different endpoints, therefore they couldn't be the same ray. Let's take a look here. Last one. Our VW, ray VW. Okay, going back to some colors here. Ray VW and ray VX the same. And I think when we use the colors and highlight, it's very clear that yes, they are the exact same ray. Yes. So I'm kind of answering the second question, different color here. Same endpoint. Same, endpoint. And they contain the same, forgot my T there, the same points, the same set of points. Not op, but of. Okay. So there's rays. I think we've kind of done rays pretty well there. The last thing we have to cover is intersections. Okay, so it's a little bit kind of just shifting gears. Everything was geometric figures, and we're still working with geometric figures, so it's not like we're going a totally different direction. But how do some of these figures that we've talked about intersect? Okay, so an intersection is where two or more geometric figures or cross, basically, or what points do they have in common? Okay. So there's two of them here. There's actually a third kind of situation that could happen. We'll just kind of lay it out here for it. There's not really a whole lot to do on this one, but add this to your note, add the figure to your notes. I've got line M. That's my only option for naming this line right here. And line N intersecting at point A. Any line or segment or ray, anytime they intersect, it's going to be a single point. It seems, I think, fairly intuitive. So we would say line M, line N intersect at point A. The one that's missing here, we actually kind of saw earlier. And this one I actually am going to kind of draw. If I have a line intersecting a plane, so there's my plane, let's call it plane X. And I've got a line that's kind of dropping down and it's passing through this plane. So let's call this line lowercase, let's just go with L, okay? And so picture this kind of dropping through, it hits this plane, and then it passes through it like a pencil passing through a piece of paper, okay? What is the intersection of this line L and this plane X? How do we describe it? We're probably going to need a name for it there. So I'm going to call this spot point A, and that's exactly what we would say. We would say the line L intersects plane X at point A. So it's a similar idea that the intersection of a line or a ray or a segment and a plane will also be just a single point. Okay. This one's tough to visualize. Well, I guess the picture isn't too bad, but you still got to kind of picture both of these planes extending forever in both directions. So it's hard. I can't really name these. We can just call it the red plane and the blue plane, but they're intersecting. Okay, and they're intersecting at every single point along this area, which we've kind of decided to call line Q. So the big takeaway is that anytime a plane and a plane intersect, their intersection would be described as a line. Okay, so I really just need us to be able to distinguish if two lines or rays or segments are intersecting, we're going to intersect at a point. A plane and a line are going to intersect at a point as well, and two planes would intersect at what we would describe as a line. So the last example we have to look at, it's got a figure here. We do have some labels on them, but it's the same thing. Every example we've done has been kind of analyzing some figures and using proper abbreviations, using proper terminology, proper vocab to describe the situation. So it's specifically asking us to name the intersection, and here's where I got to be strong with my abbreviations, of line MX. You know me, I like to highlight it. So where's line MX? It's this line that's kind of on the what we'd call shaded plane right here, or plane C. Name the intersection of that line and line A. And it's a complicated figure. There's a lot going on. We're kind of looking at three-dimensionally. There's some depth here. But if I go back to just kind of what we talked about, two lines, it's a line and a line intersecting. They need to intersect at a point. So as I look at this, I see, oh, okay, this line A, and this line YX or MX, whatever we're calling it, intersect at that single point, M. And again, I can't just do that. Be better. Use the terminology, use the abbreviations. There's no abbreviation for point, so unfortunately, we need to write out point M. All right. Last one. Name the intersection of plane C and plane D. Okay, so let's clear this here. So now we're talking about the two planes, and if I go back to my notes, it should be very clear as far as when two planes intersect, we're always going to have a line. So I need to correctly basically describe the line that this shaded and unshaded plane, this plane C and D, are intersecting at. It's along this line right here, right? If we highlight it. So what are my options for naming that line? Well, turns out I don't really have any options other than using line A. Okay, it's a single letter. It's a lowercase a. There's no point there. So I know that that's referring to the name of that line. I can involve M. Stuff that you wouldn't be able to do not do things like this. And again, sometimes I know I say don't do this, but I see it a lot. That's a common mistake. I want to use A. Mr. Crow, I thought you said always use 2 points. The problem is A is not a point. So I can't do that. I can't just do anything with this even. I see this commonly. Line A, that's not okay. There's no abbreviation if you're going to use the single name of the line. So we would have to say line A. All right, so there's lesson 1.1, very vocab heavy. It's a vocabulary heavy lesson. It's an introduction to geometry, laying down some groundwork for the school year. Okay, so add all that vocab to your notebook. Follow through on the examples. Add the examples as well. Sketch the pictures, and we should be all good to go with lesson 1.1. So I will see you in future lessons. That is all I have for today.